I'm Alessandro, and on behalf of Mathieu as well, who's sitting over there, I will tell you something about how we employed cutting-edge web data technologies to actually support the practice of crowdsourcing in lead. Now, crowdsourcing is a form of practice of aggregating data by soliciting contributions from a community. Not everybody likes this definition. Jimbo Wales of Wikipedia doesn't quite like it, for example, doesn't like that to be applied to his systems because it recalls crowdsourcing as outsourcing, therefore cheap labor and stuff like that. So yeah, while Wikipedia is a bit disputed as an example, there are actually many other examples of crowdsourced databases in the musical domain, even if mainly in the discographical domain, concert set lists, in the life science domain, the many Zooniverse projects, and our illustrious predecessor, the UK Ring Experience database. As another example, I might also show you the historical Cambridge newspaper collection, which is actually a crowdsourced project where contributors went on to provide scans and transcriptions of historical newspaper collections. How do you actually start a crowdsourced database from? Now, the old-fashioned way would be that you just have some blank, huge sheet of paper and everybody writes on it. The problem is that by the wisdom of the crowd, or lack thereof, what can happen is that the early birds, those who write first somehow into this large sheet of paper, tend to be those who eventually dictate the quality standards that implicitly will be followed by those who contribute to the database after them. Among other things, it also means that if these early birds and others do not share their contributions, especially if they are of good quality, there's a high risk of the same data, so the same indications of, like say, persons' works of art or whatever being recreated over and over again and not being connected to each other. Now, having a non-empty database to begin with can help a lot in this department. Though this might seem a contradiction, starting with a non-empty database, it is only an apparent one. As a matter of fact, in LED, we did start off with a set of curated entries to begin with. So crowdsourcing is not the only way LED aggregates content, but still it is the trickiest for a variety of reasons. Now, I'll show you a few examples of how basically the practice of crowdsourcing data can evolve from the traditional way, if we can call it that, because anyway it's been going on for not much more than a decade, to what we implemented in LED. So the basic, naive way of aggregating data as a single user who is, for example, dealing with a huge single textbook in mind, full of listening experiences from the same author. Now I'm using Benjamin Britten here because he's somehow one of the superstars of the current state of affairs of the LED database. Now, the most naive way to do so, if I were to describe a performance of La Valse, Ravel, by Benjamin Britten, you would basically enter information about the performance itself, what La Valse is, when it was performed, where, in which place, in which country, on which day, and then biographical information about the performer. Not to mention, sorry, there's a mistake here, it should be composer birth date, the same information again about the composer. And then if you were again to enter a further entry, to provide a further entry with information about something else to which Benjamin Britten was related to, so for example a musical performance he attended, having to rewrite that over and over again, the same user might just want to give up and simply cut short and indicate Benjamin Britten, expecting and hoping that the database will pick up the connection with this Benjamin Britten, this one here. Whereas, you got my word for it, it doesn't happen. Now, every current crowdsourced database has somehow overcome this basic hurdle. It doesn't take much rocket science to do so. So almost ideally, we would have, let's say, a separate independent entity, being Benjamin Britten, whom we would then be able to link in some way to the description of other resources, like the events he attended to, the performances he was actually a performer in, and what have you. Like I said, it doesn't take bleeding edge technologies to achieve this, but we can do better than this already. For example, there's also the problem of sharing what is meaningful to share, like the description of Benjamin Britten across users, so that they can benefit from having the availability of this resource, were they to enter further information, further performances, for further other events concerning this character. So the thing is, with the saying that I showed you earlier, two users still will be describing each their own Benjamin Britten, and each of these with its own degree of detail, depending on how eager each user is to provide information, and also different sets of performances, experiences, etc., because somehow they belong to the realm of the data contributed by that user. So, of course, the next step to go is to have this reuse span across the entire user base. So basically, making sure that Benjamin Britten, as submitted by a certain user, will be available for another user to connect to. Okay? Again, this is closer to optimal, but still not optimal, because we still have the problem of, in this very example, when I mentioned locations, I also introduced the need for specifying every location included, that in which country it is, in the UK. Something's not quite right with it. I mean, having to rely entirely on user knowledge in order to provide these basic and somehow common knowledge information, it kind of strikes us as a little underwhelming. But if we don't have data to begin with, this is somehow what someone has to do. The thing is, in a modern database of today, do we really bootstrap with nothing, really, with no data to begin with? I would be inclined to challenge that. I mean, wouldn't it be great if we could just store the essential information in our database, which is unique to the knowledge provided by users? So basically just have an indication of the performance happening in London or in Queen's Hall, not specifying where, and basically rely upon external authoritative data sources for the rest. So for telling us who Benjamin Britten was, what Laval's is, who Ravel was, what's Lowestoft, what's the Queen's Hall, what's London, where it is. Now, this would be the machine equivalent of, say, when I tell someone, oh, I just went to see this amazing Ravel concert, and the guy asked me, who's Ravel? And I would quite practically, if a little impolitely, answer, oh, come on, look it up on Wikipedia. Let's say we're implementing and let the machine equivalent of this. Now, the problem is that here we're looking at, sources like Wikipedia, Music Brains, GeoNames, which is a geographical database as well. We are used to consulting these databases by actually opening up browsers and going to their websites and then exploring them. So what seems to be the catch with it? It would appear that if I wanted to put the data on those websites to good use, I would have to either hack my way through to the underlying databases of the sites, or program my software systems so that they would read web pages with all the unpredictability and ambiguity data that comes with it. So a way of exploiting what we call the web of data. But it doesn't, the thing is, as of today, it doesn't really happen like that anymore. We no longer need to see the web as just a set of pages. think of doing a Google search today. Now, I am, again, relying upon the never abused enough Mozart example, but with a twist. If you make a search for Mozart today, of course, you get a ranked set of search results, but you also get, to the right side of it, a structured description of what seems to be, according to Google, the top hit of searching Mozart. So basically, we have an aggregated structured information bit describing Mozart, when it was his biographical data, and also an indication of all his works, something related to him, and stuff like that. Now, Google did not start off by publishing these structured data firsthand. Rather, it did so by compiling them out of data sources from the web, which are the same indexes for us to search. Now, one of the advantages of doing so, that basically the web, in a way, does for us the work of resolving specific entries which might sound ambiguous due to simply having the same name. Now, I promised a twist on the Mozart example, and the twist is this. Basically, we have Eine kleine Nachtmusik, which is probably best known as being the Mozart piece, of course, but it also happens to be a live album published in 1984, if I'm not mistaken, by a heavy metal band from Newcastle called Venom. That'll be the cover. Now the thing is, if you were to describe Eine kleine Nachtmusik, the one you choose among these in lead, how would you make sure it's not confused with the other one? Now, think about when you look up either of these on Wikipedia, you get two separate URLs for it. One is, for example, Wikipedia or blah blah blah, Eine kleine Nachtmusik. Another one will say Eine kleine Nachtmusik album in parentheses. The disambiguation is performed already at that level. If you go to this URL here, you get information describing this piece by Mozart only. There's no information that tells you, this URL you find information, data about the piece, the Mozart piece, but it could also be the Venom album. No, it's not like that. You go to another URL for that one. So what it means, we somehow have the unambiguous entities already discerned by Wikipedia, but not only that, also by other web services like MusicBrainz, who provide us URLs. This is, for example, a URL for the Venom album. Okay, so let's put them to good use. One way of doing so is this set of practices called linked data. As a matter of fact, linked data is not a huge set of technologies. It's a set of very basic principles and a few standards to implement them. So the basic principle is that your URLs or URIs, depending on whether we call them locators or identifiers, they identify things, not pages. Of course, if you put this in a browser, you have a good chance of seeing a page for it. But that's no longer the main product of meddling with URI. Then, once you have these URI that identify things, you relate them with one another using the URI paradigm. This is one example, one condensed example of how you would, for example, say that the Eine kleine Nachtmusik album was performed by Venom, and it has a track with a rather funny URL whose title happens to be Countess Battery. Okay? This is a very simple representation that uses mostly URIs to identify not only the nodes in this relationship graph, but also the edges. So these the properties, performer, track, title, stuff like that. Everything is URL, except for maybe like numbers or literals, like this title here. And linked data also proposes standards for formalizing these relations in a machine-readable way. So there are a few boring acronyms for representation paradigm called RDF. and the less boring acronym is SPARQL. That's where we call it for public querying and stuff like that. But again, the fundamental principle of linked data, as the linked aspect of it, is that URI should be reused. The fact that a URI for something that identifies an album, let's say, this is where, for example, Music Brains identifies the song Countess Battery. The fact that the URI starts with musicbrains.org does not mean that Music Brains is the sole authority with the right to describe the song Countess Battery using this name. Not at all. I mean, this is basically the paradigm shift that linked data provides. Everyone is entitled to reusing this name to give further descriptions about it. And this is indeed what we do in LED. We integrate data reuse as reuse of these URIs, external identifiers, within every phase of the data lifecycle. So, starting off from the moment where data are entered, when you are in front of the main entry form of data, and you're actually typing in something for a piece of music, or for a person, or for a source, you actually you are given suggestions, which you might either accept by clicking on one, or just reject by typing your own stuff yourself. What happens at this stage is that we are basically implementing the second, actually the first reuse case that I showed earlier, so the second set of boxes, where we will have internal reuse within the database and across users, but still internally within the database. If this fails because no user has entered anything about Arne Kleinnacht Music, the album, yet in LED, then we use subforms to fall back to searching within external data sources. As a matter of fact, here, for example, the band Venom becomes available because it's searched live on Music Brains and Wikipedia, which is the machine-readable form of Wikipedia. As in data entry, also we have data reuse at the moment you are searching for data. I'd rather call it finding data. So whenever you usually start a search off with a keyword search, and then LED gives you a way to refine search results and restrict to those listening experiences which have only certain characteristics you're looking for, by simply selecting from a list of search categories or facets, we call it. Now the thing is that these facets are not hard-coded in the system in any way. They are the properties that each song, listening experience, performance, whatever, has either been given during data entry within LED, or it has because they exist in the original source in, let's say, Wikipedia or Music Brains or the British National Bibliography. If those relations in a formalized way already exist, we can make them available on the fly here, not only for the categories reported in listener, music, the location, but also the values of this. Not all of these have been entered by a user within LED, but some of them are fetched live in real time from the external sources. So basically we're exploiting the wisdom of Web of Data live directly. Now, another thing it helps us is also to reconcile data that we thought would be ambiguous. So the reverse process of the ambiguity example I showed you earlier, having basically unified some data that we didn't have enough information earlier to assess they actually were a match. Now I'll give you an example with something we actually came across quite recently. I think in September we had an example of a listening experience, which I think was submitted by someone within the consortium originally, about a specific performance that was attended by and performed by historical figures like Charles and Francis Burney, the Dylan Barons, and some under-specified characters like Miss Burney, not sure who Miss Burney was, and some Mr. Merlin also we were not totally sure about. But the thing is, we had an excerpt of text, we had a quotation, and that was pretty much our source of information. Didn't have much more to rely upon. And of course, a series of performances, some of them a bit underspecified, like keyboard music. We didn't quite know what it was, but we did know it was written by Charles Burney, by Eckert, Schubert, for whom we just had names, and then performed by Charles Burney and this Miss Burney. Same thing for vocal music, performed by some Miss Louisa Harris. Sorry for not putting it here, but yeah, just ran out of space. Now, what happened then, also we didn't know when all this happened, but what happened then is that an external user, someone who is not in the consortium, entered a quotation from another listening experience record with a completely different text, taken not from a diary of Francis Burney, but from a letter to Samuel Crisp, which, however, specified the location, that at least it was in London. It gave a name to a couple of unnamed characters, so we actually found out that what was Mr. Merlin in the previous experience was this John Joseph Merlin, a Belgian inventor, if I remember correctly, and Miss Burney could be identified with Esther Burney if these two experiences were to match. As a matter of fact, we had further evidence whereby part of the musical performances were the same, and others were eventually proven to be an expansion of the previous keyboard and vocal music, but with further detail. This was enough eventually for our internal investigators to surmise that these two submissions, these two experiences, were actually relating to the same entities, to the same performance, and were providing some information. So basically it allowed some additional information, allowing us to basically collapse them into still two experiences relating to one major object, which is these performances here. Now, this kind of alignment could be done on the fly, not so much because we are reusing web data, okay, but because we adopt the same paradigm as the linked data paradigm does internally within the LED system, which means that basically every entity, every person, every performance, every piece of music is like a node in a graph, and we basically move around the references between these nodes. We don't rewrite anything. We don't have to rewrite anything, just to create the links. As a byproduct of this, the thing is, all these enhancements, all these additional information that we get, all these data, we actually give them back to the linked data community. Think of the linked data cloud as this big monster like this. I think this snapshot was taken a few months ago. For the record, it looks like something like this, where every circle you see here is essentially a data provider that conforms to those standards. I'm not expecting you to read much of this, but like Wikipedia is here, GNX is here, and all these greenish light blue is data provided by the British government. Just so you know, this country has gone a long way in providing linked data. Why would we bring a contribution to it, though? Well, essentially is because if we republish these data, in a way we provide additional information to what already exists in data. Information which we can reasonably assume to be of greater quality than the average, let's say, because it's gone through a curation process. Also, we assist information retrieval applications by providing basically further linkage between datasets. They can basically go through us in order to pass from the British Library to Wikipedia or to MusicBrainz. So basically, if this were the portion of linked data we are currently looking at within LED, so we have We have, of course, Wikipedia. We have Linked Brains, which is the machine-readable version of Music Brains. Actually, this is very new to LED. I think the big index for Linked Brains should be done like yesterday, something like that. GNAs for geographical locations, an authority file, the Virtual International Authority file, and the British National Bibliography, which is the machine-readable linked data format of what is kindly provided by the British Library. Yeah. So, if you want to chip in into this, basically we provide this kind of linkage and allow and republish a dataset. We have it actually hosted on the Open University Linked Data platform. It allows Sparkle querying, and you can find documentation on the LED website about it. What we contribute to it is, of course, new data, so historical music performances from periods much antecedent to what you can find on Last.fm, on Setlist FM, and other systems. We provide also a breakdown of the bibliographical information provided by the British Library. So on top of a book or publication, we also give you chapters, letters with the collection, diary entries, quotation of these, refinements of what is already exists, describing as a description of people, for example, and also alignments allowing us to traverse, to go from one dataset to another through us. Just as a quick figure, we have a strongly high reuse of data about people. I mean, this table here means that basically we have saved users the burden of rewriting information about the same people over and over again, about 1,700 times, and up to 184 times for a single person. Strikingly less is the one of musical items, so songs and tracks, because this is pretty much unique to every single experience. So we haven't across so many songs or albums that were described in more than one experience. And yeah, I mean, we could reuse up to 800 entities from Wikipedia and other sources, like also the UK government data and so on. And soon you will have a figure here about Music Brains reused. Any questions?